What's going on, guys? Let's do this problem right here. This question is asking to find the intervals of convergence in this power series. Let's see how we can do this. The first thing we have to do is we have to use the ratio test to find when the ratio is less than 1, right? So that's the thing we are going to find. So whatever the answer we are going to get, that's going to be less than 1. And let's go ahead and find it. Limit n approaches infinity, and the ratio test is going to be like this, right? An plus 1 over an. So this is the ratio test, and let's go ahead and plug the values. So limit n approaches infinity, and here what we do is wherever we have n, we add 1 to that. So here we are going to have x power n plus 1. In the denominator we are going to have n plus 1, right? And then we have to divide this one by an, that is original function, and dividing by this one and multiplying by reciprocal of this one is same thing. Like instead of dividing this one by x power n over square root of n, we can multiply this one by square root of n over x power n. And if you notice, this x power n and this one cancels, and we are left with x power 1, because x power n plus 1 is same as x power n times x power 1. So if we cancel x power n, we are left with x power 1, right? Now we can separate this x power 1, so we can write this one like limit n approaches infinity x dot square root of n over square root of n plus 1, right? So this is what we have, and this limit is n for n only, right? So everything except n is going to be constant. So we can move this x to the front of this limit. We can write absolute value of x, limit n approaches infinity, and this one we can take it together like n over n plus 1. And since we have the same power, like whenever we have n square over n square or whatever value, like n cube over n cube, if we have same values, the ratio is going to be the limit. So here we know that in front of this is just going to be 1, right? So if you take the limit of this one, this is just going to be 1. So finally we will end up with absolute value of x, right? So from this one we can conclude that this is absolute value of x is less than 1. Right, this is what we try to find in the first test. So from this one, now x is going to have negative 1 and positive 1, right? So this is going to be negative 1 x positive 1, right? So this is going to be the interval. Now we have to check when we apply this one to this function, this should converge. That's going to be, so we have to get the value converge. Like if it converge, we put in this bracket. If it's not, if it diverges, we put this bracket, right? So that's the limit intervals of convergence. That's how we express the intervals of convergence. Now let's go ahead and find whether it converges. So we are going to take the endpoints negative 1 and 1 and check whether it converges at these endpoints. That's the main thing. Now let's go ahead and plug negative 1 and check whether it converges at negative 1. So here if we plug negative 1, this is going to be n is equal to 1 to infinity and negative 1 power n over square root of n, right? And if you notice, this is an alternating series, because as the power changes, it's going to be negative, positive, negative, positive. So this is an alternating series, and we know that whenever we have alternating series, to check whether it converges, we take the limit of this one, limit n goes to infinity, and we have to get the limit equal to 0. So let's go ahead and take the limit. So we are going to take the limit of this one, absolute value, right? That's going to be 1 over square root of n. And if you plug the infinity in the denominator, this is definitely equal to 0. And the second thing is we have to ensure this one decreasing. And you can see as the n value of this denominator n increases, this is definitely going to decrease. so this is also decreasing, right? So this negative 1 is going to be in square bracket because this one is converging. This one negative 1 converges, right? Now let's go ahead and see whether this positive 1 converges. Now we have to again plug this value in this x and see whether it converges. Now sigma n is equal to 1 to infinity 1 over square root of n, and if you notice we can also write this one as sigma n is equal to 1 to infinity 1 over n power half, because square root is same as half, and you can see this is a p series, right? And whenever we have p series, the power is equal to 1 or less than 1, that one diverges. So this one diverges, so this diverges, so we have to express this one as 1 in this bracket, right? Round bracket. This is square bracket, this is round bracket. If it's divergent, round bracket. If it converges, square bracket. And that's going to be the intervals of convergence. And that's how we do this kind of problems. I hope you guys find this video helpful. See you next time.